Hey everybody, welcome to the last lesson on Unit 2. And so we've got one more to go after this. It's a little shorter. And then we'll be kind of wrapping up and reviewing and making sure we're good to go for the end of the semester. All right, so we have talked about exponential equations. We have talked about solving exponential equations with logs last time, but we haven't talked about how to solve exponential equations using our exponent rules. And for some folks, this one's like the hardest because you have to be able to visualize your tables for exponents. You need to know what our common base is. So sometimes that can be a little stressful. So that's why I saved it for last. All right, so just to make sure we're all on the same page with this, exponential equation is an equation, well, if I can get that right, an equation where the variable is the exponent. All right, and if you're solving these equations, there's really three basic steps. Honestly, it's two, but we always put checking as our last step. So the first one is just to rewrite both sides of the equation with the same base. Then your second step, once you've made them the same base, basically what you've done is you've eliminated, you can cross out that base, you can cancel it out, and you can just set both exponents equal to each other. And so you've just made the equation like 100% easier to solve. And like I said a minute ago, your third step is to check. This one, you're not going to run into multiple answers that where you have some that don't work. Like when we were solving for logs and we were solving quadratic equations, we did run into that. You won't run into that here. So that's a nice thing. You can more or less just kind of trust that your answers are correct, but plug it back in just to be sure. All right, so we're going to look at a few of these to start with. All right, so if you look at number 1, we've got 4 to the x power, or the power of x, equals 2 to the power of x minus 3. All right, so our first step for these is we want to rewrite both sides of the equation with the same base. So 2 is good. Over here, we can rewrite 4 as a power of 2. So 2 squared is 4. So instead of 4, we can write 2 squared. And on the right side, we don't need to do anything. All right, so we want to simplify that, and using our exponent rules, that means we can multiply. So we have 2 to the 2x equals 2 times x minus 3. All right, now our bases are the same. So those can cancel. And we can just set the two exponents equal to each other. And now it's just a simple linear equation to solve. So I'm going to subtract x from both sides, and that's going to give me x equals negative 3. All right, so I'm pretty sure that's my answer. I do want to plug it back in to check. So it's going to be 4 to the negative 3 equals 2 to the negative 3 minus 3. All right, so I want to simplify that right side. Negative 3 minus 3 would be negative 6. And so when I put those in the calculator, or if you just know your exponent rules and you do them, you're going to end up with 1 over 64 on both sides. That works. They're equal to each other. So x equals negative 3 is our answer. All right, and that's basically it. You're going to take your bases, you're going to rewrite them so they're the same number. Once they're the same number, you can cross out your bases and just solve an equation with your exponents. And go ahead and move on. All right, so let's take a look at number 2. So we have 9 to the 2x and 27 to the x minus 1. Now I know that 9 and 27 are both, I want to say factors, but not really. They both are in the 3 chain. So 3 to the first power is 3, 3 squared is 9, 3 to the third power is 27. So I can rewrite both of those with a 3 as my base. So that's going to be 3 squared to the 2x. And over here, this is going to be 3 to the third to the x minus 1. All right, remember exponent rules say we can multiply. So 2 times 2x would be 4x. So 3 to the 4x. Let me clean that up just a little bit. All right, over here, you're going to distribute when we're multiplying these out. So we have to do 3 times x and 3 times negative 1. So we're going to end up with 3 to the 3x minus 3. Okay, at that point, our bases are going to drop out. And we're left with 4x equals 3x minus 3. So I'm going to subtract 3x from both sides. That's going to give me x equals negative 3. And that's my answer. All right, so those are kind of the easier ones. So number 1, we only had to change one side of the equation. And number 2, we had to change both, but they were a pretty basic common base. When we get down into 3 and 4, now we're going to actually start dealing with negative exponents because we've got fractional exponents. All right, so 4 and 1/2, those are both in the 2 family. So 2 squared gives me 4. We just did that a little while ago in number 1. And 1/2 is 2 to the negative 1 power. So remember, negative exponent flips. So this is going to be 2 to the negative 1 times x minus 3. All right, again, we're going to multiply our exponents. So that's going to be 2 to the 2x. And then for the right-hand side, we have to distribute. That negative 1 has to get multiplied times both of them. So it'll be negative x plus 3. At that point, we can cancel out our bases. And we have 2x equals negative x plus 3. So I'm going to add I'm going to add x to both sides, which is going to give me 3x. And then to get rid of this 3 next to the x, I'm going to divide both sides by 3. And so that's going to end up giving me x to the first power. All right, if you're ever not sure, plug your number into both sides and make sure that it works. All right, over here for number 4. For this one, we have 81 to the 3 minus x, and then 1/3 to the 5x minus 3. Well, 81 and 1/3 are both in the 3 family. 3 to the 4th power is 81. And 3 to the negative 1 power is 1/3. So now with these, you can see that you do have to kind of know your exponent families. So one of the things you can do, if that's something that you don't have, like if you know that's just not one of those math facts that you know straight off the top of your head, you might want to make yourself a chart. I have like 2, 3s, 4s, and 5. That's probably sufficient, maybe 6s, and go to like the 5th power. I think that's going to probably be enough. But if that's helpful to you to have that chart next to you so you can go through and look and see, oh, this is 81 and that's 1/3, these go together. You could do that. That would totally work. All right, so from here we need to multiply our exponents. So that's going to be 3 to the 12 minus 4x. Just remember, you got to distribute to both sides. And then on the right, it's going to be 3 to the negative 5x plus 6. All right, our bases are going to cancel. And we've got a linear equation to solve. So we have 12 minus 4x equals negative 5x plus 6. All right, so I'm going to add 5x to both sides. I have 12 plus 1x, or just x, equals 6. And then I need to move that 12 to the other side. So I'm going to subtract that. I'm going to slide my work up here since I ran out of room. So 6 minus 12 is going to give me negative 6. And that's my answer right there. Again, you can plug it back in just to double check that you did it correctly. All right, last row, we're going to look at 5 and 6 here. Okay, for 5, we have 100 to the power of 7x plus 1, and then 1000 is the power of 3x minus 2. So 100 and 1000 are both in the tens family. So 100 is 10 squared, and then 1000 is 10 to the third power. All right, so now we got to distribute. So that's going to be 10 to the 14x plus 2. And then this one's going to be 10 to the 9x minus 6. All right, so our bases are going to cancel. And we're going to have 14x plus 2 equals 9x minus 6. And then we're just going to go through and subtract. So I'm going to subtract 9x from both sides. That's going to give me 5x. And then I'm going to subtract 2. And that's going to give me negative 8. So we're going to get a slightly ugly looking fraction here, and that's okay. That happens sometimes. If you want to write it as a decimal, you can. Or you can leave it as negative 8/5. It's fine either way. All right, very last one. So we have 1/4 to the 5 minus x, and we have 16 by itself. All right, so 16 and 1/4 are both in the 4s family. So that would be, 4 to the negative 1 to the 5 minus x. And then 16 is 4 squared. All right, over on the left, we need to distribute. So that's 4 to the negative 5 plus x equals 4 squared. My bases are going to cancel. So we're going to have negative 5 plus x equals 2. We're going to add 5 to both sides. And we're going to end up with x equals 7. Okay, y'all, so like I said, this is the last lesson for Unit 2. Unit 3 is kind of tying everything together. Real quickly, if you are planning on taking pre-cal next year, if you're going to be at UNCSA next year and you are planning on taking pre-calculus, or if you wanted to take AP Stats, I need you to give me a heads up. For AP Stats, I just want to know so I don't mess any of that, so I just am aware. But for pre-cal, I want to make sure that you have all the things to get ready for the class in the fall. You should be fine, but there's one little baby unit. Just like if those of y'all are taking chemistry, Mr. George has a unit to prep you guys for taking biology with Miss Willie next year. I'm going to have a unit for those of you that are going on to take pre-calc with Miss Yoakley next year. So I just need a heads up so I know how many people I'm talking to for those. I know one person has told me already, so I know that person. If you haven't told me and you want to do it, just shoot me an email and let me know. All right, everybody, thanks. I hope you're staying safe and everything is going well for you and your family, and I will talk to you soon. Bye.